Question 10 says, in the diagram below, ABCD represents a closed door, 1.2 meters wide and 2.2 meters in length. When the door is open 42 degrees along its hinge, AD, its new position is represented by AEFD. Determine the size of FAC, which is this angle between the two dotted lines. And our first step is, we can say that in triangle DCF, so in triangle DCF, we have that DC is equal to DF, which is equal to 1.2 meters. So that's 1.2 meters, 1.2 meters. And this is given. We can adapt this because this is a rectangle. So AB is equals to DC and DC is equals to DF. So if that is true, then we have that this is 1.2, this is 1.2, then 42 degrees is the angle that is sandwiched by the two sides. Then what we want to do is we want to calculate the side CF. So in order to get the side CF, we can use the cosine rule. So we can say CF is equal to DF plus DC squared plus 2 DF DC cos D, like that. And then we can make our substitutions. DF is 1.2 squared plus 1.2 squared plus 2 times 1.2 times 1.2 times cos of 42. You put this all in your calculator and you will get 0.86. And remember to square root. So CF would be equal to the square root of all of this. That means CF is equals to 0.86 meters. So this is 0.86. Then what we want to find next is these dotted lines. If we can get the lengths of these sides, then we'll be able to get the angle of question, FAC. So in order to get these sides, we see that this is a right angle triangle. If I were to highlight it in green, you would have that. And over here and here, this triangle over here has a 90-degree angle there. So we can, what can we do? We can get the size of AF using Pythagoras theorem, saying AF squared is equal to 2.2 squared, which is AD squared. So let me say AD squared plus DF squared, and then AF will be equal to the square root of AD squared, which is 2.2 squared, plus DF squared, which is 1.2 squared. And AF in this regard will be equal to 2.506. So 2.506, and that is in meters. Then once we have AF would be the same size as AC because it's still the same door. So this AC is also equal to 2.506. Now we know the three sides of a triangle, and we know the three sides of the triangle, and we're looking for this opposite angle, which is something we can do with the cos rule. So if we say CF squared is equal to AF squared plus AC squared minus 2BC. Okay, here I made a little mistake. This should be minus, but in computation I use the correct sign. So the answer still stays the same. It just should be minus 2 BC over here. So minus 2 dF dC. So at this point, minus 2 times AF and AC, AF times AC multiplied by cos of the angle in question, which is, you can call it angle A for now, but it's angle FAC. Then what we can do is we can make cos FAC subject to the formula to get cos FAC alone on one side. We'll take this 2 to the other side, and then we'll divide by that. So this will give us CF squared minus AF squared minus AC squared, all divided by, so this will be negative 2AF AC. And then we can make our substitution. This will give us cos FAC, then 2.506 for CF was 0.86. So 0.86, can just leave that negative outside. 2.506 squared, 2 CF was 0.86, so that would be 0.86 squared minus AF and AC are both 2.506 squared minus 2.506 squared, all over 2.506 times 2.506. Don't forget this negative over here. It's going to be multiplying everything. And if you compute this, you get cos FAC will be equal to 0.9411. And take cos to the other side, you get the arc cos of 0.9411 would give us 19.8 degrees.